My presentation, I'm going to cover a few things. So before we even look at the BIM dimensions or the facets of BIM, I would like to remind us of what BIM is, what BIM is, and then we look at BIM, the nature of BIM information models. Then from there, we look in detail at the fundamental uses of BIM, which is now a deeper look at the BIM, the various BIM dimensions. And then I'll take you through 3D BIM. We look at model-based design coordination and clash detection. We look also at 4D BIM, which is about model-based planning and control. And then at the end of it, we look also at 5D BIM, which is about model-based estimating and quantity takeoff. So what is BIM? I think in the previous sessions, if you attended the first part of the training, you might already have gotten the definition of BIM. But in this case, BIM refers to a collaborative approach to delivering projects that integrates project participants in one shared dynamic database where information about the project that is used for supporting decision-making is found on this database. And as the project progresses from one stage to another, you find that all the project participants, including the architect, the designers, the engineers, the conservator, the contractors, input information to this model. So it keeps on changing and is continually updated as the project progresses. It is also important to note that this methodology or this collaborative way of working is majorly supported by software, is supported by technology, and that is through BIM supporting software. And of importance also to note is that it is based on the work processes of the people that are involved in the project. So it's not something that is very new. It's information technology being used to automate and support the existing work processes that have been there in delivery of construction projects. But of course, that is done with recognition of the industry procedures and government regulations that govern the construction industry in the country that the project applies to. But beyond modeling, I would also like us to look at BIM as building information management, which now we will be talking about the processes of generating, collecting, retrieving, disseminating, sharing, storing, and sharing information about the proposed facility. And beyond management also, we can look at it as optimization of building information. And this will help us to recognize the need to make the best and most effective use of this project information, which is for project participants to be aware of the decisions supporting information requirements of other participants and be able to produce and share the right information at the right time in the right file formats, and with the right details to help whoever is receiving this information to make decisions faster in executing the project. So that is basically what BIM is. Let's go to the nature of building information models. I'm noting here that a BIM model is formed by an aggregation of library of intelligent BIM objects, building components, and building elements that are linked together in a database that is also rich in non-graphical information. So we have the 3D part of it, which shows the spatial relationship between elements and components and the whole building in terms of its relationship with the immediate physical environment. And then we have text descriptions describing what kind of materials are making up these elements, what type of building finishes do we have, what type of materials are we using for doors and windows, and all that is found as part of the model. Important to note about BIM is the automation part. And the automation part here, it means the BIM objects, the elements, and the building components that form part of this model, they are used to represent like a floor plan on 2D view, and the other relevant views such as the plan, the sectional, the elevational, detail views. And there is also non-graphical cost related and facility management related information, which will be found in the elements schedules. So when there is an update, in this case, when there is an update that is made either on the floor plan of the model, that update is going to be automatically reflected in the other views, in the sections, in the elevations, in the details, in the schedules, if your BIM model is set correctly. And depending on what stage of construction or what stage of the project development we are in, you will find various names given to these information models. For example, you'll find a design intent model that is developed during the design stage. And then the model is developed into a virtual construction model. This will be during the construction stage where the contractors and subcontractors are involved. And when that information is then passed to the operations and in-use phases of the project, we have the facility managers inputting the data to help them to operate the project well. That would result to an asset information model. So basically, when the project is starting, the project team would agree that okay, we are going to implement BIM in this project, and we need to have the information needs of every participant taken into consideration. So if you are being involved as a quantity surveyor, it is important now when there is something called BIM execution plan is being developed at the earlier phases of the project, you communicate to the project team that you're going to use these models for quantity takeoff. And this is the software that you are using to do quantity extraction. These are the file formats you would expect to receive from the engineers and the architects. And this is the level of detail, the level of development, the level of like information that you would need for the model authors to put into the model so that when it comes to you, you're able to use that reliably for cost estimation purposes. So that's basically how information models are constructed. We go to the BIM dimensions. When we talk about BIM dimensions, this refers to the level of information in a given building information model. So we're looking at it from the perspective of what kind of information is being inputted to this model so that we can support the fundamental uses of BIM. Because this model, with its information, it's, as I'm saying, it's a database, and we need this data to be relevant to the members of the project team so that every member of the project team can rely on this information to make decisions for executing the project. So if the QS wants to do quantity takeoff, they can rely on the elements and the information in the model to do that. The contractor wants to build on site, there is some detail that they want to see how materials or components are connected together. They can see that from the model and like that. 1D and 2D is not really the collaborative part of BIM. It talks about text-based specifications and descriptions and two-dimensional drawings. Two-dimensional would mean, like if it's on a floor plan, we have the length and maybe the width. On an elevation, we could be having the length and the heights. We have like thicknesses of the walls. and so on. And 3D is about geometrical and graphical information. And this helps us to show the interrelationship between elements in a three-dimensional space. So if someone is modeling a column, you're able to see that column in relation to the existing walls, the existing floor slab, and all that. And also the whole of that building and the other facilities that are modeled. So you can see the relationship between them in a 3D space with maybe the civil infrastructure that is around that, or the external immediate natural environment. That would mean the trees and vegetation and all that. When we talk about 4D now, the three-dimensional geometrical and graphical model is linked to a construction schedule. See how we develop construction schedules using a Microsoft project or any other software. So that can be imported to a 4D BIM software like Synchro or Navisworks. And then the model is model elements like the floor plan. If you're saying you're going to be from week 1 to week 2, you're going to be working on the substructure part. So the substructure part as modeled is going to be linked to the items in the construction schedule as that. If week 2, you are doing your slabs and beams, columns and beams and slabs for the first floor, that is connected also to the schedule. So at the end of it all, when you are looking at your construction schedule, you can also see a 4D simulation of the construction process. So when you are in week 1, you are seeing a simulation of the substructures being built. Week 2, you are able to see a simulation of your RC superstructure getting built. You go to 5D, and this is where cost information is added to the model, or building quantities are extracted to the model and connected to an estimating software so that we can be able to develop cost estimates and bills of quantities even at the very earliest stages of the development of the project with more accurate data. So if you look at the traditional takeoff where you are using blueprints and measuring rulers, I think that takes a lot of time. But then the automation of also being able to measure from PDF drawings add an improvement on that process. But also, if you look at that, the capabilities that BIM offers, if the designers and the model authors are able to accurately model and create all elements and components and objects, and the schedules are correct, you can extract those schedules from the 3D model and use that for cost estimating. You can link this 3D model to a cost estimating software such as CostX and be able to measure quantities from the model directly, while you're also seeing the model in 3D so that it also improves the visualization of the project. 6D is about environmental sustainability, energy efficiency, simulations, and analysis. So in this case, the use of BIM in this case of 6D is that when the model has been created using the BIM authoring software, could be a case of Revit or HackCAD or Tekla structures, you use third-party specialized software or plugins that can be embedded in the software, in the BIM authoring software itself. So if it's Revit, maybe a plugin for Revit, and that plugin is programmed in a way that it is going to be to use the information that the 3D and the text-based information on the performance of materials, maybe fire resistance ratings, environmental material ratings, and use that to perform environmental sustainability and energy efficiency and simulations and analysis on the model. So it's required that information on the environmental performance of materials, information such as the embodied energy and energy consumption data is actually part of that model so that these simulations and analysis can be possible. And this can be used to advise on maybe life cycle costs such as energy costings, heating and air ventilation costings, and all that. 7D refers to the uses of BIM in facility management, and it represents BIM in the planning, the use of BIM in the planning, management of maintenance operations through the building's life cycle. And the asset information model is developed to capture the as-built information. So as the project progresses from design to the construction phase, it is getting updated. So during the construction phase, the as-built information is captured. So if there were any changes to the design, they are incorporated. If any materials were substituted, those materials are incorporated in the model. The data about those materials are also inputted in the model, so that then when we are handing over this project to the client, we'll also, instead of handing over a file of hard copy drawings or PDF drawings, we're going to add over a BIM model. With that, important facility management information, such as maybe manufacturer names for the components that you have, if it's electrical fittings and all that, plumbing fittings and fixtures. You have warranty information, maybe operational notes and manuals, product codes, technical specifications for all that, and any other facility management related information will be part of that 7D. So the importance of this is that it is going to help facility managers to plan for the proper operation and maintenance of the building. So for example, let's say there is a certain building component that needs replacement. Maybe it has malfunctioned. So for the building manager to replace that, they need to have all the information about that component so that they can make an order for a material to be brought in. So in this case, information concerning that component, including things like manufacturer contacts, will be found in the model. And if the manager needs to procure another one from them, they can just give them a call. And we can also be having information such as the technicians who are skilled in fixing of these components, so that when the building manager is looking for that information, they can easily find that information on the model. As we go to now a deeper look at, as I said, 3D, 4D, and 5D, it's important to look at how construction information technology progressed from paper-based, traditional paper-based processes to what we are currently now discussing. So the traditional processes usually involve the 2D drawings and the text-based specifications, maybe drawings made on your drafting table with your pencils and all that, and you have another specifications document, but these two are not linked together. But then as IT advanced, these drawings could be created on a computer using a software such as AutoCAD. And this is the practice that is called computer-aided drafting. And it also advanced to a point where you would get software for measuring quantities from these PDF drawings. If you have the plans and the elevations, you could measure areas and lengths and perimeters from these drawings. This is the practice that is called computer-aided estimating. But then BIM, as we are looking at it, now developed from the advancements in 3D CAD, which made now the model that is developed from 3D a dynamic one. Dynamic means that if you look at the other process, you had to do your floor plan. When you are done with that, you do the elevations independently, you do the sections independently, you do the details independently. You share that with the QS to do the takeoff independently. But then the 3D model has this, the floor plans, the elevations, the sections, the details interlinked, meaning that if you were to update one, let's say you update elements in the 3D view, if you go back to the other views, the floor plan, the sections, the elevations, you'll find that update has been automatically captured in those other views. So there is a lot of time that is saved there. And then The ability to link text and non-graphical information now has fueled the development, these other dimensions of BIM that we are looking at, the 4D, the 5D, the 7D, and all that. Let's look at 3D BIM, which is about design coordination, clash detection, and resolution. So in this case, you will need to have a BIM authoring software. You can have ArchiCAD, Tekla Structure, SketchUp, you can have Revit, the model review software. Solibri is a model review software. I think Navisworks also works the same way. We saw earlier that a 3D model would contain these intelligent BIM objects and building components and elements, building up the information model. So these objects and virtual components will have 3D information, as we said, length, width, and height, surface materials and finishes, and the likes. So in 3D BIM, we expect the architectural, structural, mechanical, electrical, plumbing, and civil infrastructure models to be collated together to form a federated information model. And this is now the model that is going to be used to perform clash detection and resolution of those clashes. Clash here, we are talking about clash because in the model we are having the architectural elements. We are also having the structural elements. We are having mechanical, electrical, and plumbing elements. So if there is any conflict, maybe in terms of the graphical placement of electrical or plumbing elements with structural elements, so that needs to be resolved first before we go to site, because if we go to site and we find these interferences and we are trying to solve clashes while we are working on site, that is going to cost us more time, because we'll have to start now coordinating the design while on site, and that time would have been used to do other more useful activities. And in that case, maybe if the contractors that had done the construction, you'll see cases where there are reworks, and that comes with a cost implication. So clash detection or clashes would occur in two ways. There is geometry-based clashes, and this is the case where two objects or elements are interfering. So you see that, like heating, ventilation, and air conditioning elements interfering with a structural beam. We know very well that we should not interfere with the structural part of the building. So if there is such kind of a clash, we need to look for a way of having like an optimal way of rerouting or repositioning our HVAC conduits. There's rule-based clashes. And in this case, you do certain, you code the rules, or you put certain rules that your design or the design should meet. That is, like an example, if you find that in the model, you are having a column that is placed on the ground slab without an appropriate footing, you know very well that there's a clash there, because the slab is not able to take the loading from the columns. So the column needs to have a footing for that. And I think it's also useful in experimenting and trying to see if the building design that has been developed by the architect is really meeting the building requirements or building regulations or space requirements that the owner had requested in their client brief. So how is design coordination and clash detection and resolution useful now to a quantity surveyor? I think first, if you look at having 2D drawings and taking off quantities from these 2D drawings, there is a lot of information in terms of the graphical representation of the elements that you are not able to capture directly from 2D drawings. But if you had a 3D model and plus your 2D drawings, you are able to see how walls are getting connected together. You can see how beams and columns are coming in. You can see how the electrical and plumbing and mechanical aspects are coming in visually, which in this case improves the clarity and improves the understanding of the projects in this case, and is going to help you as a quantity surveyor to come up with, I think, better estimates and quantities, unlike when you are using only 2D drawings. And it can also be used as a tool for cost control, because that's a domain of the quantity surveyor. Because if you look at the case of clashes and conflicts, field conflicts, as we discussed, HVAC and BIMs, in that case, if as the QS you had received the models before you do your quantity takeoff, you have reviewed the model to maybe detect if there is any clashes in any of these elements. You know very well that if these clashes go to the construction phase of the project, they are going to be more costly. But then in this phase of planning, when we are doing the simulations, I think the cost of making changes is lower than when we are working on the construction site. So the elimination of field conflicts is going to reduce reworks on site. And in a way, it's something that we can use for cost control as quantity surveyors. Also, the roles of the QS now start broadening from the traditional roles to a role like design review as part of the QS work, which the QS would add more value to the project team by reviewing the model before takeoff to ensure that they are properly modeled and there are no clashes that are part of the project. So we are going to have fewer change orders, less cost overruns, and an improved site productivity at the end of it all when we use 3D BIM appropriately. So let's move to 4D BIM, and this is about schedule simulation. The 3D model, we said it had graphical data. So we are able to see our building, the proposed facility, in a 3-dimensional view. And 4D, this use now, we put in the time aspect. Time aspect comes in with like the traditional practice of developing a work program. So now this work program has the specific tasks and the start times and the end times linked in the program. So we'll take parts of the 3D model and link that to the tasks in the construction schedule. That can be done using 4D scheduling software such as Vico Office, we have Synchro, we have Autodesk Navisworks. And this approach makes it possible for the project team to visualize the whole construction process or just some phases of it and see how the timing of these tasks is going to affect the workflow on site. And that would include resolving time-based clashes. Maybe if there were items in your construction schedule that if you're looking at it from the text-based version, you're not able to see that maybe you had scheduled your first floor slabs to be constructed earlier than the columns and the beams. So we know very well that these slabs are sitting on the beams, which are transferring loads to the columns. So we need to have the columns first, the beams, and then the slab. So you're able to detect these kinds of time-based clashes, and it is going to help verify the planned sequence of works. In this case, we are looking at it visually. I think visual representation gives a lot of clarity. And there are two ways that I've identified, in this case, which 4D BIM can be used in construction. There is something called phase planning and site utilization planning. So we are able to plan if there is phase 1 of the project, this is how phase 1 is going to be built. This is how it relates to phase 2. This is how the delivery of materials relates to phase 3 and 4 and 5 and such things. Then there is site utilization planning. In this case, the information models are used to visualize the permanent and the temporary facilities on site during the multiple phases of the construction process. So we are able to link this model to the schedule, and we can see the space and sequencing requirements that are needed on site. We can also see information on labor and materials and equipments their planned deliveries on site, how is construction equipment, the movement of workers, and the movement of visitors going to be in a 3D simulation. So that's the site utilization planning. So it allows the project team to identify potential and critical space and time conflicts. A conflict would be, for example, there is movement of equipment, movement of labor, there's space requirements for storage, space requirements for working. So if there could be any conflict in terms of the transportation and the storage and all movements, we'll be able to see how that works, how the crane moves around, how the vehicles delivering materials are going to be moving in, and we can optimize that so that when we go to site, we have the full picture in mind of this is how my site plan looks like, this is where all these activities are organized around. So in this case, the QS can explain visually to the client what phases of the project have been built. And in this case, I think it will be very easy for the clients, especially those that are not do not have a background in the built environment. It will be very easy and effective for them to visually understand that the contractors worked from this time to this time. They've worked on this phase of the project. We can see maybe the substructure and the first floor is done. So when we are authorizing payments, the client sees the visual part and can connect that with the visuals on the site and the costs that are required or the amounts that the contractor has raised as invoices for the work done. It is also useful for the QS in reviewing and advising on construction timelines. I think also time control as cost control also is an important aspect of the project, because cost and time and schedule tied together really influence the success of the project. And then let's look at 5D. And 5D is the use of BIM in quantity takeoff and estimating. And in this case, this is where the quantity surveyor plays a very central role, because it involves the use of the developed model to extract quantities and the quantities of materials and associated costs for cost estimating purposes. But in this case, it's important to have in mind that the same way computers work, there is the rule that says garbage in, which means if the quantity surveyor is going to rely on this building information model to extract quantities of materials, to extract maybe labor associated quantities, the information that is put in that model should be very accurate, so that the costings that are coming out of that are also going to be very accurate. And that's why it's important for the quantity surveyor to understand how this model is developed, how a 3D model is developed, to be able to also, like, you can model the 3D, you have basic understanding of how the construction schedule is linked to this model. Also, skills on how to manipulate this model, maybe to extract quantities from that. Maybe you want to extract window and door schedules, wall schedules, surface finishes schedules, and all that to help you in cost estimating. So the model authors need to search for the level of development required to support cost estimation for this to be possible. And this level of development, we talked about it sometimes later, is an agreement that says at this stage of the project, this is the participant who will be the biggest consumer of the information that is being produced. And these are their information needs. So when we are creating these models, we need to put the information that is required for these people to use this information to make decisions. In this case, for the QS to make decisions on cost and advise the client and the rest of the team. The process involves generation of quantity takeoffs from the models and linking this to a cost database to compute a cost estimate. BIM cost metadata can be exported to QS software, such as CostX, where the QS now manipulates the model to extract building quantities and add descriptions from their database and come up with a bill of quantities. Now, the importance of the use of 5D BIM in this case, in estimating and quantity takeoff to the quantity surveyor, one thing we can see is accuracy. Because when you are manually doing the takeoff, you get tired. I think sometimes the accuracy might go down. But if you are using computers, and this is an automated process, I think the quantities and the cost information will generate from these models. If they are properly modeled, will be very accurate. And even in the early stages of the project, we'll be having information that we can use to advise the client and the project team on costings. So it also reduces time used when doing manual takeoffs and allows the estimator to focus more on value-adding activities. And this could be stuff like contract and procurement advice, price comparisons of various materials, helping the team design to cost instead of waiting for the team to complete the design and then costing the design. So I think designing to cost is a more value-adding activity for the clients. And things like business development, I think they are also very important, because you have to look at how the business is going to continue growing, how you are going to get projects so that you are able to stay in business. So also the visual process where you have a 3D is actually a very helpful thing, because you also get to understand the project way better than if you were taking off from 2D drawings. So that's it about building information dimensions. As we've discussed, we've discussed what BIM is. We've looked at the nature of information models. We've looked at 1D and 2D and the development of construction IT to what we have, 3D BIM, 4D BIM, and 5D BIM, how all these aspects of BIM can be useful to the project team and the quantity surveyor. So thank you for listening.